This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 91, a quick look at what is new in Ansys Fluent 2021 R1, as well as news and events from the world of Ansys. Greetings, my name is Eric Miller. I'm one of the co-owners here at PADT and your host for these podcasts. We're going to do a really quick intro today before we get into our topic. It's been a busy 2 weeks at PADT as we start to meet people face-to-face and travel a little bit, and we're just busy. So we recorded this interview today on Monday, the 28th of June, which is about a week late, and the podcast itself will go out a day late tomorrow on the 29th. So we apologize for that, but we'll also kind of keep it short so that we can catch up. I will note, I did have my first kind of big business meeting. It was a conference, really, the Arizona Technology Council Biotech Conference, which is an annual event, and it was our first live event here in Phoenix, and it was fantastic. I hope to do more. It was so good to see people that I've only been seeing it on screens. And the thing that really came home to me was the big difference of going to that conference versus doing all these virtual events that we've been doing is I met new people and built new relationships. That's something that's really hard to do in a Zoom meeting, and I really enjoyed it and look forward to doing more. So as a preamble, today we're going to talk to Tom Chadwick, and he's going to give us kind of some input and his thoughts on the really important things that are Ansys Fluent 2021 R1. There's some cool stuff in there. There's actually a lot in this release of 2021 R1 of Fluent, and we picked the most significant, the three most significant that we thought, and then talk at a very high level about some others. And I'll let him explain more. I want to welcome everybody today to another discussion about CFD with one of our in-house CFD experts, Tom. Tom, welcome to our discussion, and thanks for taking the time to help me figure out what's new, because it's a lot.
Yes, it is. They're doing a lot of work with the codes.
And this is, correct me if I'm wrong, but we're talking about the 2021 R1, which has been out for how long?
It's been out since late January.
Okay.
Of this year.
So it's been out there for a while, and we expect the R2 to come out soon, but we felt that it's time to really dig in a little bit into both heat transfer and flow using Ansys Fluent, and get into some specifics. And I'll confess to our listeners that when Tom and I were talking before, we realized it's too much to cover in a podcast. So it's going to cover what we think are the three most important enhancements at R1, and then maybe a little quick overview of what is more. But you have a webinar coming up, right, Tom, that's going to go into the detail? When is that going to be?
That is this Wednesday.
Okay, Wednesday, which is going to be the end of the month, 30th, right?
Yes,
30th. Yeah, the last day of June. So join us for that if this whets your appetite on some things. So the thing that got me most excited, and I don't know, maybe because I'm back to being wanting to be an astronaut when I was a child, is the hypersonics, what we call high-speed numerics.
Yes.
What's the coolest advancement in that subset of the code?
They're doing a lot of stuff with increasing the accuracy of the calculations. So they've improved the numerics of the code to better capture shock formation, better capture the changes to the material properties because whenever you have hypersonic flows, the surface temperatures can get very high, especially near bluff bodies. And at those high temperatures, you can't treat things as a normal perfect gas. They actually break down. And so they've added in a lot of ability to handle the material properties. So they have a two-temperature equation model, which is basically non-reacting mixture where the flow is in thermal non-equilibrium.
Okay. I'm looking at it, and there's a lot of very specific terms and equations.
Correct.
And that are being added, which I think is very important. These are the things that people using maybe a different code to do hypersonics, or maybe haven't done hypersonics because Ansys didn't have it in Fluent. It's getting in there, and multidimensional shock waves in an unstructured grid. That's going to be, because I know that meshing's always been a big bugaboo in hypersonics, is getting that perfect mesh that kind of looks like the shock. Right? In the past, you kind of had to make it predict where the shock wave was and mesh appropriately, right? So we can avoid that.
And so now you've got the ability to do adaptive meshing, where it can, as the calculation progresses, it figures out where the shock is and refines the mesh there to better capture the shock shape.
Cool. And as we all know, there's a lot of things that weren't hypersonic that are getting there in the future. Looks like you're going to go over a few examples, including a reentry capsule, which is pretty cool.
Yes.
That's anything you want to add about some of the examples that are in there?
They're doing a lot of stuff. Examples of like the aerospikes for high-speed missiles. They often put a small spike at the front of it to help reduce the stresses due to the shocks, the bow shocks. So they put a little spike out at the front to generate a shock, and that results in some fairly complex shock structures.
Right.
And so there are improvements to the ability to capture all the effects of those aerospikes. In addition, there's also a lot of stuff about re-entry capsules. So like all the SpaceX Dragon capsules, they used it to design the SpaceX Dragon capsule to predict the stresses, thermal stresses, and pressure loads due to the re-entry.
So every billionaire that wants to do or has his own space company needs at least one copy of Ansys Fluent now.
Yes, correct.
That's a given, right?
Yes.
Yeah. So I knew there's a reason why I wanted to be a billionaire.
Yes.
It's really it's its own physics, right? It's CFD, but it's its own physics as well, right?
Yeah, it's CFD, but it really is its own physics. You really, when I did work back in the 80s on this, we had to have our own special codes. Even standard ways of calculating efficiency fall apart at high speeds because because of the reactions going on within the bow shocks and the shock waves and near the surface. Your efficiency calculations the normal ways you calculate kinetic efficiency don't work. So you had to come up with we had to come up with our own special way to calculate efficiency.
And now that's all there. And of course, you can always, if it's not there, you can always talk to us or your provider about a user-defined function that we can add in if we need to. So
correct.
I know we've done that in the past for some of our customers doing hypersonics. Very cool. Yeah. I want to talk more about hypersonics. Like I said, it's really a fun topic for me, but maybe even a broader set of our listeners will be interested in all the cool enhancements to heat transfer and radiation.
Yes.
So what's the big change there?
The big change now is that they've got two new ways to calculate the conjugate heat transfer. So you're calculating the thermal heat transfer inside of a solid body, as well as the heat transfer effects happening in the flow. It used to be that you had to solve both of them using the same time step, which doesn't always accurately work that well because the time step for the solid body is very different from the time step for the flow.
Right.
But now they've got two different methods to solve the solid bodies with one time step and the fluid bodies with a separate time step. So you can run a transient solution on both the solid and the fluid at the same time.
And this is using the Fluent solver for the thermal heat
Correct.
transfer in the solid, not solving in
No,
the
it's not a
mechanical
coupled.
for thermal. Right, not a coupled.
Correct.
So this
It's
is
not
good.
it's not a coupled solver. It's all within Fluent.
So that staggering was something that you kind of had to use the external solver for in the past, and now it's built in. So that's
Correct.
That's very cool. And then so that's for both of them allow that, right? Both the new solver.
Both of them allow it. They're just two different methods. One basically solves the fluid at multiples of the multiple time steps within a single solid time step. And that's necessary when you're dealing with a transient where it's important that the solid and the fluid stay in sync in time. The other one allows them to sort of get out of sync during the solution process. But at the end, when you get to a sort of a steady state final solution, the solid has reached some kind of a steady state temperature field.
Nice. Okay. I like that. And then along those lines, I was a bit surprised to learn that there is an actual strain solver in there as well, so you can get your thermal deflections. Is that true?
Correct. Now they've got the ability to do the thermal stress on the part. It actually allows for a coupled structural solution within Fluent. So if you've got, say, an object, a cold object that's sitting in a hot flow, and it's moving back and forth, it'll handle the changes in material properties as a function of the temperature and allow for that thermal stress.
So it's another example of, instead of going to a coupled solve with, say, Ansys Mechanical, as long as it's relatively straightforward, you can actually do that all within Fluent, which is fantastic. I love it.
Yeah. They're trying to get basically to a point where Fluent can be its own standalone tool that you can use to do a lot of things that you used to have to do, coupling it with other solvers. And now you can do it all within Fluent, correct.
And this is where I be the old guy and talk about how we were doing this in Ansys, what is now APDL, 20 years ago. Of course, the solver was not nearly as good. So we could do it all solver, but the Fluent solver was not Fluent for sure.
Correct.
So good. Anything else on the heat transfer side that you want to bring up before we pop on maybe radiation?
Yeah, they've got some improvements for the radiation to allow for better modeling of the radiation inside the solid and the radiative properties of the solid bodies.
Cool. And that's really important. I think sometimes radiation doesn't get the attention that it deserves, especially in a fluid. Yeah. But it can be a dominant heat transfer.
Yeah, if you get to anything where you've got either a high temperature body or a very low temperature surroundings, like space applications where you're dealing with things that are, you're radiating out to a black body, basically, the radiation becomes significant because of the temperature variation.
Right. And they also sped it up, right? It looks like it's 3 times faster for some of their test cases, calculating view factors. So, that's big. Yeah. It sucks sometimes that your view factor calculation can be, if it's not parallel enough, right, can take longer than sometimes your solve. But it looks like that 3x speed up is significant. Yeah.
Yeah.
That's cool, especially if you've got a moving source in your transient. So that's really cool. Love seeing that enhancement. Again, another thing that increases the functionality, and maybe people are doing oversimplifying or using a different code to do that. They can now do it in Fluent. So cool. Well, the third topic we wanted to talk about very quickly, and is another one that's very exciting. is overset meshing. And let's start with maybe a little bit of an explanation of what overset meshing is, because if you've not used it in a different code and you're a Fluent user, you may not quite know what that means. So what is
it's something they've added in the last I think 3 versions of Fluent. And basically what it allows you to do is create a background mesh which describes the fluid domain. Mm-hmm. And then you can build a solid body, a missile body or an object that's falling, anything like that, a bullet moving down a chamber, mm-hmm. Anything like that. You can build a detailed mesh around that body and then allow that body to move through the background fluid domain. And it automatically calculates an interface as that body is moving through the background domain to better capture the effects of what's going on around the body.
Rather than remeshing as the body moves.
Right. Rather than remeshing the entire domain, mm-hmm. all you're doing is remeshing at the boundaries between mm-hmm. the mesh around the solid body and the mm-hmm. background mesh. So it's a much faster way to calculate your moving meshes, and it allows you to have a much better overall mesh quality. Mm-hmm. So you can build a nice orthogonal regular mesh around your solid body, mm-hmm. and then the only place that you have say an adaptive, that the mesh needs to adjust is at the boundaries between those two bodies, which is away from the main area of interest, which is the flow around the body.
Sweet. Yeah, it's and we actually some inside thoughts on that is we had a salesperson for a while here that used to work for a competitor in the CFD space, and he said the only way I could beat Fluent was if the customer needed offset meshing or overset meshing.
Yeah.
All right. And that otherwise there was no way I could get in there. Right. And so now that we have, and I won't mention the company, but now that we have overset meshing, that differentiator is gone for that. There's no reason to have that code because it was relatively limited for other things. So this is another example of, being able to do more with this code.
Right.
So that's an overview of overset. What's new in this?
They've made some advancements in what you can model with an overset. Mm-hmm. For instance, now you can use the pressure-based solver.
Oh, good.
A segregated pressure-based solver with the overset meshes. In addition, now you can. One of the limitations of the overset mesh used to be that the mesh couldn't adjust, it couldn't be adapted while you were running the solver. But now they've allowed you to use their polyhedral unstructured mesh adaption. So now you can, as the body is falling through the domain, you can adapt the mesh around the body. So basically you further refine the mesh mm-hmm. where the body is so you can better capture things like the shocks or flow disturbances, like if the body is generating a wake as it goes along, you can adapt the mesh downstream where the wake is, and it'll automatically adjust it.
Nice.
Yeah.
So that's probably really useful, especially for flow over like cars and planes and that kind of stuff, right? Yeah.
Correct. Yeah. And, one of the examples they have here is that it also now works with the volume of fluid.
Oh, okay.
Solution. So now if you've got, for instance, say a boat mm-hmm. Bobbing along in the water and you've got waves impacting the body, mm-hmm. You can capture refine the mesh where the boundary is of the volume of fluid.
Oh, nice. Okay.
And capture that. So it allows you to better capture things like the wave surface mm-hmm. and how the flow breaks up as it hits the body.
Right, because it actually separates, right? As it does things, yeah.
Yeah.
So that's so very cool.
Yeah.
Really that's a whole other area that I used to say we don't care about because we live in the desert. But as PADT has expanded into California and Texas, we're seeing more and more of these sea applications, and really kind of is it a pun to say we're really getting our feet wet in that area?
Oh, bad pun.
Sorry,
bad pun. Yes, it is a pun, but a bad one.
But a bad one. It's actually pretty exciting stuff, and
yes.
Again, you used to have to use a specialty code for. So love seeing that. In there. Cool. So those are our big things, right? Hypersonics, massive improvements in heat transfer, overset meshing capabilities, which if you've not looked at, definitely need to take a look at because it's probably applicable to whatever you're doing in different ways. Just really quick, what are the other things that are new at 2021 R1 that you think people should know about and come to your seminar to learn more about?
They're making a lot more improvements to the turbulence modeling, adding in some features to better capture local effects with the turbulence. They're also making improvements to the acoustics and your ability to solve acoustic waves and acoustic effects. They're also doing some stuff with structural modeling, so you can do fluid structure coupling and model that all within Fluent rather than having to go back and forth between Fluent and mechanical. You can stay within Fluent and solve simple structural motion problems within Fluent. They're also just making some improvements to the numerics of the code, so they're adding in new capabilities to better handle things like poor mesh numerics, which has historically been one of the problems that limitations of Fluent is that Fluent is more sensitive to mesh quality than CFX, but there have been making a lot of improvements to Fluent to better handle situations where you might have a local issues with your mesh and still be able to solve correctly and get good solutions.
That is something that may, of all the things we've talked about, if you've dealt with trying to get a good, well-behaved mesh and couldn't do it, that may be the biggest advantage to everybody of all this that we talked about.
Yeah. One of the other minor things is there another unique solving tool that they've been adding into Fluent is what they call an adjoint solver, which basically allows you to do optimization of body shapes based on effects like improving your flow solution, so you reduce the amount of pressure drop that you have, increase efficiency of your bodies, or increase the thermal efficiency, heat transfer efficiency, things like that. The adjoint solver allows you to do it, and it basically distorts the solid body to minimize those effects. And they've been doing a lot of improvements in the capabilities of that as well.
That's that capability has been around for a while, but is really every release just keeps getting better and better and more useful in a broader range of applications, it seems.
Yeah, it's been for a while. It's been a sandbox thing where it's something that's neat and fun to play with, but it's limited practical capability. But now they're really working with it heavily. I know one of the guys that's one of the primary developers of it, and he's pretty much been full-time dedicated to improving the adjoint solver.
Yeah, we do have to remember when we get these new features that there is one or more people somewhere at home or at an Ansys office in the world working away at writing code and checking code and compiling and sweating the details so that we can turn on that feature and get this great improvement in capability.
Right.
Yeah.
Yep. Yeah.
I'll add one that I found looking through the notes that that I think is kind of bittersweet but cool. The death of Fortran, they've added C++ support to the built-in compiler. So if you are doing your own user-defined features, and you don't speak the ancient language of the forest wizards, Fortran, that now you can do it with C++ and don't have to find some special compiler or get an external compiler to do that. It seems like it's built in now, which is sad for me, but I guess a good thing. Fortran is 60 years old now, so
it's getting a little long in the tooth.
No one knows it but me.
Yes.
So good. Anything else you want to add before we wrap
one of the other minor things, and this is kind of a secondary thing that's not very sexy, but they're doing a lot of stuff with the file formats to improve the speed at which the files can be compressed and written out and read in, so that because when you're dealing with a really large model, one of the things that's often takes us a fairly substantial amount of time is just to read and write the files. Right. And they've improved the format of the files so that they compress faster and so that the solver can read them in and start working faster. So,
well, it's like twice as fast or more. Yeah.
Yes. Yeah. It's a substantial speed up.
Or I'm looking at the writings. Wow, that's significant. 273% faster. So that and when you're talking about these files, that can be minutes, right? 273 minutes faster, or hours.
Yeah, I mean it can take for some of the meshes that they're building now for Fluent. You're talking, especially some of the really complex flows. You're talking 200 to 300 million cells. So those files can take 20, 30 minutes to read in and read out. And if you can cut that time in half, that's a substantial improvement.
Especially when you're iterating. Wow.
Right.
Yeah. So I'm looking at the notes and wanting to bring up other stuff, but we're running out of time. So we'll use that. There's even cooler things like more on solid motion specification and details on some of the numerics that Tom brought up, and all sorts of good stuff with pictures and Tom's expert commentary on top of it. So please do consider either going live to the talk, or as usual, you can listen to it in a recording afterwards to understand more. And I know I keep saying this and I'll keep saying it. I'm just always impressed by how they keep adding really substantive improvements to the code every 6 months. And this is yet another example of, these aren't minor tweaks and enhancements. These are major new capabilities. So, cool. Well, Tom, thank you very much for joining us, and you're always insightful in educating me and hopefully our listeners as well. And we look forward to we won't do it as soon as R2 comes out, but we look forward to seeing what else is new in R2 when it comes out, and continue this journey of making Fluent a better tool.
Yep.
Thanks, sir.
Sounds good. Yep. Sounds good.
Bye.
Bye.
So I want to thank Tom for humoring us and coming on and sharing with us what he's learned so far. And again, you can learn more from him and get into the details on his webinar, which is going to be on the 30th on Bright Talk. And as always, at brighttalk.com, you can go back and listen to our recordings, so you don't have to be there at noon Phoenix time for that one. But do check it out and learn more. If you're a Fluent user, I really recommend that you check it out, because there is a lot there, and sometimes it's really hard to keep up with everything. And so you may be totally unaware of a capability or be using a third-party code to do something that we can now do in Fluent. That was kind of my big takeaway, is a lot of these things that we were using other code for, we can now do in the software itself. And for our commercial today, I want to talk about something, I guess I just kind of made up the phrase, CFD assistance, right? So going that extra step for these new capabilities are areas of the code that you're not familiar with. So the first step is to really talk with your Ansys salesperson, hopefully that's PADT, to understand what is there, what's in the code, and what licenses you may need to take advantage of these new capabilities and these new features. That may include Elastic licensing, which we've talked about in the podcast before. It could be Ansys Cloud Solution or a third-party cloud solution, because you may want to do like hypersonic, but you don't have the horsepower to do that. So how do you get that access? So talk to whoever you get your Ansys from, and they can help you with that. Then also consider coming to PADT, doesn't matter where you are, and working with our CFD experts for some mentoring. So maybe it's understanding new capability and how to apply it. What's the right options to use for what you're trying to do. Maybe you just need an expert to answer your questions and to be a sounding board as you figure it out as you go down the path yourself. And of course, we can always help out by customizing and adding any missing capability with some of the user programmable features, or maybe working in the user interface. So there's a lot we can do from a mentoring standpoint. It's really helping you use the code more efficiently and better, or figure it out. And then, of course, you can also come to PADT to do simulation as a consulting contract. And we can then wrap some mentoring and some training into the end of that, so that that knowledge that we gain solving your problem using our experts is transferred back to you. So there's a lot of options there to help you do advanced CFD, and please consider PADT your partner for that. Don't hesitate to reach out and ask us how we can help you learn and use these new capabilities in Ansys Fluent, or just be more efficient and better at the capabilities you already know. The Ansys stock is going up. So the market just closed when I recorded this. It's about 1:30 Phoenix time, which is the same as Pacific time this time of year. And the market closed at 4 Eastern, and it finished at 349.13. So it's been going up. It's still down from that all-time high of 413.19 in February, but it's working up for that dip in March when it was at 393. So we're working our way up. I can't really complain about that keeping happening there. It's down 4% for the year, though, and the S&P 500 is up 14%. So it's got a little catching up to do, and hopefully we'll do that soon. Ansys news-wise, the only official news story was about the success that a corporation, which PADT has worked with some of their divisions, called Meggitt, has had with Ansys products. It's a good article that kind of looks at why Ansys has helped them meet this kind of, the big takeaway is that they cut 6 months out of their production time for their products, and they boost the performance of the product in the process. And if you've ever listened to one of our sales pitches, that's what we say. Using simulation with Ansys products will cut your production time, your time to market, and you'll get a better product at the end. And this is a real world example of that happening. And it's kind of nice to see verification that what we say actually happens, and here's some proof for it. So if you're considering how to improve your products or to get your products to market faster, do take a look at that Meggitt story as a real world example of doing that. We don't really have any PADT news to share with you, so skip over that section. And let's talk about the Ansys blog. There's 3 articles that I found of use in there. The first one is aptly titled, How to Mesh and Simulate Welds with Ansys Mechanical. This is an evolving capability within the tool, and not necessarily so much as a feature, but a process, right? We've always been able to model welds. What's the best way? What's the most accurate way? How do you mesh it? This has definitely been evolving over time, and this article kind of gives us the state of the art of where we are in that process. The next blog post from Ansys that I really wanted to point out is called Access 70 million plus safety data sheets from Granta MI. What's this about? Well, I talk a lot about on this podcast, and we've had people on to talk about why Grant is such a great tool, such a fantastic addition to the Ansys family, managing your materials, keeping track of them, getting access to material databases. Well, one of the whipped cream features on it is that there are 70 plus million safety data sheets in Granta MI. And if you've ever had to manage safety data sheets, even here at PADT, it's kind of become overwhelming. We have these big yellow books that we put out. It's been a real pain in the butt. So having Grant to take care of that is just an additional reason why you should be looking at the Granta suite of products to help manage your materials and use them with simulation. And then the last one is called Cool, Compact, and Comfortable. I'm going to pronounce this wrong. Podbike Friccar redefines the velomobile. So what is a velomobile? What's a PADT? It's a four-wheel electric bicycle. I guess it's not a bicycle if it's four wheels, but it's kind of that kind of a structure, right? So it's a relatively thin, lightweight structure. It's got a nacelle around it. The user sits inside. They can pedal, and it's also electrical as well. And I'm fascinated by these small vehicles ever since I watched some of the upperclassmen when I was in college do a solar-powered three-wheel bicycle. It's been kind of a fascination because it's really taking engineering to an extreme to make as lightweight a vehicle as possible. And it's another great example of using simulation, Ansys simulation in this case, to get there and to come up with a practical product that really works. That is, as the title says, cool, compact, and comfortable. And it really is kind of a cool looking thing. On our blog, King Lee just published a really useful article called Simulating Electrical Windings, Solid or Stranded. So if you've ever done an electromagnetic simulation, in this case we're talking about Ansys Maxwell, and you want to know, and you've got stranded wires that you're moving current through, and you want to know whether you should model them as solid, just kind of smear the properties as solid, or you want to model them as stranded. This answers that question. When do you have to and when do you not have to? Why does it make a difference and when does it make a difference? So King really laid it out in a nice little article. And again, that's called Simulating Electrical Windings, Solid or Stranded. Upcoming event-wise, we've got the webinar that we talked about, heat transfer and flow updates in Ansys Fluent 2021 R1. And then on July 14th, Tom is going to come back and talk about Ansys Rocky. So he's been learning and studying Rocky. If you listen to earlier podcasts, we've had the Rocky folks on. We've talked about it. Well, while we've been talking about it, Tom's been learning it and using it. So he's going to give his experience and show some real-world examples of how to use it. So check that out on the 14th of July, again, live or recorded, either way, and that's going to be on brighttalk.com or our website, padtinc.com/events. The only other upcoming event that we've got is I talked about how wonderful in the introduction it was to go to a live event. It was the Arizona Technology Council event on biotechnology companies and technology here in Arizona. Well, our next big event is going to be the Aerospace Aviation Defense and Manufacturing Conference. It's going to be in the afternoon of the 15th. It should be well attended, even more so than the biotech one. And it's always a great conference. It's always one of my favorite events of the year because many of our customers will be there speaking or just listening in. And if you're in Arizona, you should definitely come. I'm going to be doing a panel on electric vehicles and battery manufacturing in Arizona. If you're not aware, we're kind of becoming we are a hotspot for that. We've got multiple OEMs manufacturing vehicles here, as well as a growing number of battery companies doing their design and manufacturing in Arizona. So we're starting to get a real concentration in this space. Of course, Ansys is a fantastic tool for electric vehicles and batteries. And so that's not what we're going to talk about in the panel, although I'm sure if you listen in, you'll hear me sneak in a couple references for Ansys. But it's really about why they chose Arizona, what challenges they face in the industry, getting their electric vehicles or their batteries on the market and in people's hands. And so these are real experts. We'll have some folks from Nikola, from Lucid, and then some small companies like nPower and Zero Energy Vehicles, which is all of these are Ansys users in one way or another. So do check that out. And I said it was going to be short, and I think I kind of kept it to that. So I want to thank everybody for listening in once again. Don't forget to subscribe to our newsletter at www.padtinc.com/opt-in. That's how you can keep up to date with all the Ansys news, including this podcast. And speaking of this podcast, please subscribe to it at whatever tool you use to listen to podcasts and let your friends and coworkers know about it. And do not hesitate to reach out with suggestions and ideas. And I want to thank everybody for listening in. Thank you for joining us for the All Things Ansys podcast, episode 91. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.